Hello everybody and welcome here to this Robox video. My name is Marco Walter Bassignana and today I will show to you some AGV Manager plant. First of all, while you install AGV Manager, or let's say in order to install the AGV Manager, you can come here to the Robox website. Let's go to the home page, let's go to Catalog, Products. Here, let's go to the AGV line, let's go to the products, and then finally here we can see the software for the AGV. Here you can press software and here you may find the AGV Manager, the AGV Handler, which is the archery program stored inside your controller, and the RAT, which is the Robox AGV tool, the map drawer. As we have seen in the previous videos here, these are the main key tools of a Robox system. Together with them there is the digital dispan, which is the HMI, but the digital dispan program is already loaded in the HMI you will buy, and so you will have no need to care too much about this. And together with this, you will be provided with the source files. So in case you want to modify it on your own to add your customized pages, you will be allowed to do so. And if you do not have time or the skills to do this, don't be afraid, because Robox staff is always available to help you developing your best AGV system. Thanks to our more than 30 years old experience in the AGV field, we may give you the right suggestion, the right hardware, and of course the best software possible to make it possible. Now, let's reduce all of this and let's take a look not just to the beautiful seaside of Italy, but here to my desktop we have the AGV configurator and the AGV Manager. While you have to install the AGV Manager, you will get these two programs. They are together provided by the AGV Manager installation. The AGV configurator, you can see, is the key part, and the first one you have to switch on. So here we can see the directory, and so let's go to this to choose the project we would like to play. And okay, this is a demo of 3 yellow AGVs we are playing here. In the main page we can see some settings like the language and the name of the main source file we would like to use as the main script. Then we can see some other things like PLC protection. Here we may enable or disable the emulation of the vehicles. Keep in mind that this is protected by password, and this can be enabled or disabled only by the high-level technician. Then here again, inside the AGV Manager, you may set some kind of password for higher level installers and technicians. And finally here you may set what kind of folder you would like to use to make a dump. But now let's go forward. Here you set the map. The map is the one we generated before with the RAT. If I open it again and I just open a project, so for example this, when I have done everything I can press here on generation, generate the map, and in case maybe I can add some other path where I want to save the generated file. Now here I need to set the name of the generated map. In case I can rotate, I can fit, I can set some other settings to show the map. Here I can set the things in case I want to load the map online to the AGV just directly from the AGV Manager. This is something that I always suggest to do, but in order to set these values, you need to contact Robox staff, because we can tell you which are these string and register according to the project you are using. And finally here there are some other things we do not care too much. It's advanced people. Here in the AGV you set the base AGV address, and so this is the base TCP/IP address of the first AGV. And please keep in mind that you must put all the AGVs connected in an increasing one-by-one address. You are not allowed to make some strange mapping. They must be sequential one to the other. So if you have to put 23 AGVs in your plant, please keep in mind to have 23 consecutive addresses. Then here we can set some other kinds of settings for the communication. Then here you can set the communication between the AGV Manager and the PLC stored in your plant. As we know, in your plant you may have a PLC that could be something standard, serial connection, all the stuff, but maybe some Siemens, some Snap 7 or S7, or another Robox controller, or something connected in Modbus. You can just connect to one of them and then set all the necessary data like the IP address, the port, rack, slots, and the data blocks you would like to exchange. Then later, if you go to the I/O description, here you may define the groups and you can set what kind of information are available and the groups you would like to use. Finally, here in the database you may enable a MySQL or Oracle or Microsoft SQL server, and these are the kind of database we are used to deal with, and maybe the customer plant will fetch some data to us like the emissions or like some information about which station in the plant is now requesting our AGV, one of our AGV, to go to serve and do some kind of job. And again, also for the report, you can ask to write a report on some kind of database. Now let's take all of these out, and I can close this, and just to make an example, I can show to you a real existing plant where you can see the I/O mapping. I switch on the configurator here. Okay, I already changed the project, and now here you can see the PLC in this case was a Snap 7. Here we have some of the data, and here we can go and check the I/O groups. Now if I make it bigger, we can get more information. So here we may define some objects, and here below on the right we may set for each object what kind of data we have, the kind like unsigned 8-bit, some single bit information. Here I can see the available library, so for example I can just drag some information here and put it bigger and put it here, for example. Now of course I'm doing something that I should not do, so I just come here and I need to cancel that stuff. Let's say this is winder, this is, let me remember, okay. Now I kill it, no. Okay, sorry, to delete, I have the delete part. Yeah, I'm always forgetting that part, sorry. Very well, and here, so we can see after I do the object, I can just create, save them, and just drag here to make the configuration. You can see that our data can be so big because anyway it's just a communication with the PLC, so it's something not so heavy, not so high. Even if I have a giant plant I have to play, we can put more and more data, and per each one I can also set a name, while here when I put them I can just come here below, and for example I'd like to put for example here, maybe do putting here a winder and make an array of data, for example. And in this case, I can say how big is the array, where is the initial point, how many elements, and maybe also write some text, some name for them. That's easy part we use to create our data. Now I can't cancel this, okay, delete it, and that's done. But now let's go to see, do you want to quit without saving? Yeah, I don't want to modify an already existing sample. Now, when the configuration is done in your manager, we can just start it. Oh yeah, now I press enter, and in order to change the path, after enter I keep pressing Alt button. So I open the menu and I go here, and I go to see this 3 yellow program and open this. Okay, I say save and quit, and now let's begin the manager. Alright, here we have the AGV Manager, and here we can see an example of what we can play. Now, for example, here we have a map. In this map we have 3 machines called 10, 11 and 12, and we have a storage unload station. Here we have 2 battery charger points, and here we just have a parking station. Now, here up we have some buttons to play some of the main functions. And here, pressing on the AGV, I can choose which one I want to contact with, and here I can see some LEDs telling me that I already connected with them. Now, of course, they are emulated AGVs, but in the real plant, you can check here to see which AGV is connected and which one is missing. Then I can go to see, for example, some plant settings. Here, for example, there is the main log of the AGV system, and here we can read something written by the system that we can use to get more information. Here there are alarms, here there are some other statistics, and here we can get the information on any single vehicle. Now, vehicles are doing nothing, so there are no missions and no commands, but you see I can just scroll and see all the AGVs and check more things. Battery, power, if it is loaded or unloaded, if the AGV, this is some user information, so it's not necessary, and some other stuff. And finally, here in the I/O page, now there is nothing because I never set the communication with PLC, but in case you have, here you will have all the LEDs and for the input and output to see the communication, which LEDs are on and which are off with the communication to your PLC. Now, in this case, we already have this plant has started, and now let's, for example, check. I simulate the PLC. I have enabled this AGV, just right click and enabling. Now this one can also be right click and enabled. If I want to enable them all, I will already put a button here to enable all. So now also number 2 is enabled. Now here, pressing this button in this demo, I can see which machine is calling me, if they are working, which AGV will be assigned to each machine, and so I can check also their motion and everything else. This simulated plant is also allowing us to do this form. This form is something I made myself to play this plant. So in here we can just go on the installer part and open the editor form. This is just a Qt designer, and here, for example, you may choose some kind of standard picture, open, and then you can just put some vertical layouts, make it bigger. It's just some easy and standard Qt part. We can put some radio buttons, we can put some edit. Now I have to remember, some text edit, for example here, or line edit. Okay, here 1, here 2, and so on. We can just add the pieces we need, then we just give them a name, and according to the name we can save this. Now of course I do not want to save, and then call it thanks to the script to be shown here. We can create a button and make it useful to enable and disable the system. Now let's take a look at our AGVs playing. Now the AGV number 3 is making a move to charge mission. So the AGV is coming here and now it will just have some timeout. I can click here and see AGV3 is charging, and we need to wait 12 seconds. While the other AGVs are just telling me some more information about the mission they are doing right now. Now AGV number 1, the red one here upwards, is just waiting here registered to one station, and AGV3 that now stopped the battery charge is now following it, getting in the queue in order to connect, and later they will all go to the stations when the product will be ready and they will load it. I would like to tell you that this demo is very beautiful, but it is also, let's say, a complex demo because it is using some of our biggest and widely developed algorithms in order to handle the load and unload of many machines. But just for this demo it's spectacular, and so I can show you that the AGVs may move thanks to the program, or like in this case I just right click disable number 2 and I can just click on it and drag somewhere. The best way to play your map at the beginning when you want to check if your lines and curves are nice, if you made the AGV move in a correct way, if it is not hitting any kind of column or walls, and if you have done a good job, is just to play like this. Now, for example, AGV number 3 is so boringly waiting as now there should be the product, okay, and it's coming. Yeah, after the AGV3 is coming, for example, I can take AGV number 2 and just ask it to be dragged. For example, I can say I want this AGV to go to Park Point in case I want to do some kind of maintenance. I can ask the AGV to go here. I can just make some step-by-step mission, but if I just want directly to send it here, I can do it. Now let's take a look instead at number 3. Number 3 is going to this point. You can see that the path of each AGV can have some continuous line, like this one, and a dotted line. So the continuous line is the part of the path which is requested, while the continuous line is requested and also reserved. While an AGV is requesting a path, it just says that this is the place where it wants to go. Like now the AGV1 would like to go in this path. But since AGV2 is now locking this place, AGV1 is not allowed to reserve it. So now let's take AGV2 and move it away. Now AGV2 is already reserving now everything of its path, and when it's free, the AGV number 1 is also allowed to make the continuous line and reserve all this path. Of course, reserved means that no other AGV will be allowed to touch this line. There will be no cross and no other AGV can come here. Only this AGV will come, and the others will just remain in the requested part. More requested areas may be overlapped by more AGVs, but only one can reserve it at a single time. Now, you can see, for example, now the red and green are requesting the same path, but only green can reserve this part. One AGV is going forward as long as it can reserve the path, according to the next point, that could be the generic point. Did you remember? If you have seen the rat map, you know that I said that putting the generic points is useful to let the AGVs to make the motion because they can reserve their path. They reserve a certain distance that later I'll show to you in the code where to set, and this distance is what the AGV will reserve, and will be sure to make that kind of piece of movement. If the distance is longer, you know that the AGV will never stop, and normally this can be a help because the AGV will move only when all the path, when bigger part of the path is free. But for this reason, other AGVs will not be allowed to cross, and so if you have a more AGVs system, it can be you may have more problems and less efficiency because more AGVs will just wait even if the other AGV reserving the path is still so far and they have the time to cross. For this reason, people really prefer to make shorter reserved distance, just enough to have the AGV not to stop and start, so to have enough distance to keep having a straight movement. Otherwise it will need to stop and start, decelerate and accelerate again, and this is boring. But apart from this, using shorter path is allowing more AGVs to move in closer one to the other at the same time. But remember, this could create some deadlocks in case your system is not very well developed, in case you made some errors in the map. Now, for example, you see all the AGVs are only allowed to move in counterclockwise way. Of course, imagine one AGV who would like to move in a reverse way, like clockwise, it would automatically lock all the line, because imagine the AGV1 who wants to go back, AGV3 wants to go forward, and so there is no possibility, and there would be no solution to that situation. This would be a deadlock, so a dead situation with no possibility to go out. For this reason, the best way to avoid deadlock is to draw a clever map in your RAT. So remember, keep using one-way only points in your map. So go to RAT and touch the points, and I'm sorry it's Italian, but when you say allow the direction, don't say everyone, but say either only forward or only backward. Keep everyone only on some generic lines, like for example here the parking lines, because the GV can go backward to park and forward to go again to work. But normally on the working lines you should think about single directions. In this way you will avoid 90% of the deadlocks. And then remember, in case you have crosses, the AGV should never be allowed to stop too close to the cross, otherwise it could also create some kind of deadlock. Imagine an AGV stopped here on this point, which is the beginning of the curve. This means that another AGV that we imagine that is in this station will never be able to go forward, because this one will be big enough to occupy one part of the cross. For this reason, we always put our generic points far enough from the cross point. In this way, while the AGVs will stop, they will stop either here, you see right now the green AGV has reserved until this point, and then later maybe it will reserve either until here or all the curve until the next point. Now we will see. Now it's coming down, now it's okay, it's not reserving. Okay, now it did. So, okay, in this case it just reserved all this path. And so this means the AGV should never be allowed to stop on the cross. So don't put generic points too close to a cross. And apart from this, many other things are the ones you may learn just by playing. Some other experienced tricks are not the ones I'm explaining you now in these videos, but the ones I can help you understanding while playing together with your plant. That's also because every plant is different, and sometimes you just need to reason about the traffic rules and try to figure out what could be an impossible situation and how you should behave in order to avoid. But now let's answer to the most important question: how to rule all of these AGVs. As we have said in our presentation, our AGV system is like a horseman. You can see here this toy, this picture of a toy of a Roman soldier, this horseman. And we have said that AGV system has two brains, the horseman, the human brain, and the horse brain. While in the previous videos we talk about the RC program, the digital dispan, and we say that the AGV will have its object blocks and the RC program. The RC program is currently this one. I can show to you here. And here in the program we just have oscilloscope, some sensor page, some graphic panel, and other oscilloscope. And here we have the configuration we have, for example, the device of the antenna, and here we have the axis, and here we have the tasks and the rule. And here the flash folder images you need to load inside. This part is the horse brain part. So this is the part you will put inside your RP2, which is moving the kinematics of your AGV, which is in our symbolic view of the horseman. The AGV is the horse, while the AGV manager is the horseman. So we are now talking about the mind, the brain, ruling all the system. And we would like to know how we have to write the program. And so let's take a look. As I said before, this is a big program, so don't be afraid of something so big you will see. Here in this program we can see the red parts, which are the function list here in this script. Let's say that mainly the script is always divided in two ones. Even if you start with the demo script of the empty project you may easily download from the internet, you will see this structure. So there will be a common script making the most common things, like register a movement to some point, or set some missions, and some other easy things like text and so on. While normally you go to the main script, and here you have to deal with all the important things. First you can define the version and the mission codes. The mission is the key of the AGV's behavior. Every mission is done by many other sub-functions which are called macros. Every macro is doing something. One macro is moving, one macro is waiting, one macro will ask the AGV to load the requested material and to unload, and some other macros may do some more things. Then there are micros, which are more little things happening inside macros, like for example write some registers, or wait some timer, or do some operation like requesting in fact to the RP2 to do some kind of operation. So I will ask the RP2 to load, and so the RP2 will use its own RC program to move the axis to do some kind of operation. And finally, here we define some interesting points on the map. Like in this case we have first station number is number 10, and we say that we could have up to 999 stations. And then we say the load station can go from 10 to 12, and here there are these machines. And below, the unload stations are 20 and 21 that we can see here. 20 and 21. And then we may have the charge station. We just say they are 2, and then ID of first CBT is a system value, so we just define the ID of charge station just using this value and this value plus the charging station minus 1. In this case they are just 2, so I could just make it easy and say this plus 1, but this is a generic program. And then the waiting point is point 200, that I think is somewhere here on the map. Maybe it's this one. No, that's 201. So maybe it's here below. Now I can't see. Maybe it's here. No. Okay, anyway, it should be somewhere on the map. And the parking point is 250. Then, okay, the vehicle is talking to us thanks to some status bit. We have already seen here that I can go here in the plant and talk with any AGV, and here I can get some information about power. You see on power, load is not present. I can ask AGV2, AGV3. You can see, for example, this is no power. This now is powered and with the load. I'm sorry for Italian, but carico presente means loaded AGV. While instead the number 1 is carico non presente, which means not loaded. And here we can go and see the history of previous missions done. So you can see, for example, here we have made, we have made many missions. So let's go back to the mission definitions. Sometimes we have mission 12, which is mission unload. In fact, it's unload to the station 21. Then we have mission 1, move to the waiting point. Then mission 10, which is move to the winder 12. Mission 11 is a load, and then again there is a mission 12, which is unload, but the station was different. Now the stack added some other missions and cancelled the previous ones. But here you can have history of some of the last missions, and here you can see how much time it requested to do, what kind of macros were inside. If your AGV is locked in some point, you can just come here, see the current mission, see the macro which is now doing, the ones still not done, and inside the macro, if you want, if there are some macros, you can see them. Now, okay, only in this case there is one micro here, here more micros, this is the movement micros, you see. Now they are all done. This is a very powerful debugging tool to understand what's happening. Now, let's go back to see the code. So here you define the missions, here you define the macros. And then, of course, later on we are just defining here the bits. As I said, the bits we would like to see here. To see the first 4 are system reserved bits like on power, loaded or not loaded, having or not having commands to execute, and so on. While other bits are free to the user, so you can write here everything you want. And then here you may set some user form. For example, the user form is something we need to deal with this Qt designed form. And so that's just a variable. If you want to know more information, you can just come here and press Ctrl F1 to open the manual. And inside the AGV Manager manual, you can get all the information you want about all the methods, about the functions. I can call it, I can get some information, I can see things, and so on. And here I can get more and more information on any kind of things. I suggest you to begin from the tutorials. I do not exactly remember, yeah, here. No, it should be, sorry, Q to winders, movement, access, information. Okay, I'm sorry, but I know somewhere there are the tutorials, and if you need them, you may just ask to Robox staff and you can get more ones. Now let's go and keep an eye on this one. So here, this is a big code where I set some I/O. This is the I/O copied from the real plant from which I got this demo. Then some winder data. Then here some local variables local to the task that actually will be global to the system. You see, I can have a Boolean, real, integer variables. I can have some timeout variables, and here many others. And now let's begin talking about the application functions we have here inside. On application start is the first function we may see here. This is the function, the constructor, so the function that is called only once at begin of the AGV Manager. Here inside we may see something like, okay, this is just the version, and here we have the XMAP parameters. These parameters are very important, very useful, and for example, we can get more information by pressing Ctrl F1 like always and opening the manual to see all the various fields, all the various functions, and so on. For example, we set here the set symmetrical vehicle dimensions, and so we say that the vehicle is 1 meter by 700 millimeters, and the center point it's symmetrical, so the center is at half. Then we set some flags, like for example we say don't stop on cross points, true, This means that the AGV will not be allowed to stop on a cross point, otherwise it could lock it and forbid many others AGV from pass through the cross point. Another possibility here, set don't move if destination on reserved path. False. So in this case is disabled. If I set it true, I would enable this function that will forbid the AGV to move if the destination point is already reserved by another AGV. And so set don't move on destination move. This okay, it's again a Boolean parameter. Yeah, maybe this is because again the destination could be reserved, but up to now I do not remember, I'm sorry. And then finally we say AGV set map parameters and par, and so we are setting all of these flags and providing to the plant. And now here we set, this is an important parameter, AGV set movement length 5000. This is the length expressed in millimeters, so this is 5 meters, and it is the important distance of the reservation of the path. While now we see, now let's make it play again. I ask the AGV to come here. Okay, we see that up to here is reserved, now until here. So this is the closest point at 5 meters. Now one more, you see. Now I'm quite sure that maybe after the curve we are going to have something more. So this distance is almost 5 meters. The first point after 5 meters is the one that will be reserved by the current AGV to move. Then we set, okay, set of existing load, okay, so just something to set the kinds of existing load. Then here I wrote on myself a for cycle, just for example to check if the point does not exist, I do nothing. Otherwise, I would like to append to some list. Here it is a lot of stuff for the handling of the load and unload. This is the queue handler of the AGV Manager. This is a very expert stuff I'm not explaining now, but here we are just extending and we are adding some properties. For example, here I say if the station exists, we would like to add the property reserved to the AGV. And in this case, so only one AGV can reserve that station at a time. And here we also set some text. So in this case we set machine while we have the load and unload, and so we see here on the map machine 10 to 12. So they are just labels. Then we do the same. These are the CBAT, so the charge of battery points. And here we do just this stuff. Then here we configure some of the buttons. This is the buttons to enable all the AGV. This is an unload queue we enable, and as I said, I'm not explaining this because it is a very complex algorithm. If you need to use it, you will just use some predefined program already made by us, and we will be very happy to help you to customize it for your needs, because this is one of the most interesting kind of plants we deal with. So we make a lot of settings according to masks, reservation areas, waiting points, lines, and so on. Then we have some battery simulation. This is just something I wrote. I just make a timer. I make a timeout, which is 60 seconds plus a random according to this maximum value. And this is the battery. We can see battery time is seconds to timeout. Okay, I will just write it. And so this is sometime the kind of system. Oh, sorry, I have to enable this. Otherwise I will destroy the system. And sometime we can go and check the timeout to the battery. I think that part is something we write here in the report. Now let's go to the end of the report and let's take a look, because sometime I'm quite sure we will have to set here in this part. Now I can't find it quite easily, but I'm sure here it's written this information, because this Qt debug is something that will be stated here. All right, then uploading station. Okay, here I'm just telling something about other queues, and here I'm writing things about the user form. This is my user form. You can see it here on the right. I made it and I set the values, the initial values, to all the fields here. Some boolean, some real values, and here some integer values, so that you can see here the minimum and maximum loading station, minimum and maximum unloading station. All right. Then here there is the application stop. This is just the destructor, so the function that will be called only once at the end of the AGV Manager when you want to close it. Now we just do nothing and we just do return true. There are many other functions. Here you see we set some comments, we set many things. Let's just take a look here on the left in the function list, where we would like to see some of the most interesting functions. For example, on update.io, this is a function which is called every time it's synchronously in the loop of this script, and I will do it to play with the input and output. I will check if some interesting input arrived, if some necessary output has to be fed, and I will check, for example, semaphore. We may have traffic lights, of course, in our system, and we can give the red light or the green light according to the request of some AGV. Or, for example, here we handle the watchdog IO. Here I just set a timeout and I will modify just this variable. Other things we can do here, current mission, I'm just feeding some variables that maybe we would like to also to send to the AGV and show on the HMI, and other things. Here on status change is a function that is called every time the status of the AGV changes. And so, for example, here we may set some description like AGV online, AGV debug, AGV offline. This is, for example, the string that we can see here. We can see AGV online on the third line of this part of each AGV. As you can see, this function has in its argument the uint, so the integer unsigned variable of the AGV counter. In this way, we will always be able to set this status description to this AGV, and we will provide that kind of value that is 1 per each AGV. Now they are all online, so you can see, but if something is different, you can see that other things change from one AGV to the other. In case on AGV dropped point, we make some safety checks if the vehicle exists, if the vehicle is not in automatic, if it's not enabled, and so if the current mission is 0. If all of this is good, I will just make a register mission to point. So you can easily understand that's what we play for the drag and drop. And if in case I take number 3 and I say I want it to go here, it will do nothing because the AGV is already enabled. So I need to disable the AGV, let's say cancel the current mission, and then I can just take it and drag it here. So as you can see, here we're getting inside the AGV dropped to point. This is a standard function. You don't need to edit this. If you open the default code of any AGV Manager project, you will see that this is already done. And so the drag and drop is the standard function you will always have. But now, as you see, when I want the AGV to move automatically, I right-click and I can enable while it is disabled, of course. Now that's already enabled, I can read disable. And when I enable the AGV, it must go here and go to the on next mission. This is the most important function because this is the ones called by each AGV. You see again uint AGV, and here we will generate the mission according to what is possible. Here this is an empty function normally, where you just may have some few lines, and here you may write your own code. So for example, first of all I check that the vehicle exists. Alright, some safety checks, and here I check some input if the status of the AGV is allowed, and this comes from the R3. So let's talking about our horseman symbol. We say I'm asking to the AGV if the bits inside are allowing me to move. So if the AGV is correctly powered, not alarms are present, and the operating mode is correct, and so on. And then, okay, here I have the simulation that I have made here, because otherwise I would not be allowed to play. That's because it's just a simulation flag. If so, I will go and check some modes that again comes from the status of the AGV, and these are some user bits I have defined on my own. Here I check the current station, and now I check if I am in the mode online. For example, I will do some check. I will check if I am allowed by the PLC, okay, and then I will just check if I am loaded or not loaded. In case I am not loaded and my battery is low, or in case my timeout of the simulated battery is finished, so I will make a for cycle asking to all the charging stations if they are reserved to no AGV, and if I will call this function, this is something reserve station to AGVs is something I have written, so it's just a customized function to see if I can reserve the station to my AGV. If I can do it, my next mission will be a mission charge, and I will just do a register mission to the mission charge. Register mission is another function we are soon going to check, but it's just the function when you define per each mission the kind of macro you want to put it inside. In case no station is available, I will just go out to the park point. Battery is low. You can see here the debug part, the debug message I want to print. The battery is low and chargers are busy, so I go to park and I will just get out. Otherwise the AGV would remain locked in the unload station and not allowing the other AGV to move. In case the AGV is not allowed to go because the battery is low or for another problem, please keep in mind that in your map you must always have a station, a parking station, and the AGV will go there. Or normally just go to charge. And again, otherwise here I say, okay, battery is low and charger is busy, otherwise AGV does no mission. This is the case that the distance from the parking point is less than 100. So this means the AGV is already arrived in parking point. And in this case, I'm doing nothing and I will return the mission null. So the AGV will just stay there and wait until something changes, until maybe the battery is better. Or maybe when the battery is still low but the charger is free, and so the AGV will somehow be able to go to charge its battery. Otherwise, if the AGV is loaded, I will do a lot of things here. Do not look too much at this. There is a lot of code, but that's due to the algorithm I have developed for this program. Let's say that normally, if the AGV is loaded, I would really like to register a mission to unload, to the best unload, which is just something I have written, and that maybe I have found in this for cycle. I check all the unloading stations, I check if they are available, if the kind of load I have now on my AGV is allowed to be put in that unload station, and if so, I will register that mission. And that's it. Otherwise, if I'm here, I will just go to a waiting point, and then from the waiting point I will go to load again. Otherwise, here I may have a debug mode. This is something that in this kind the user wanted to have. And if I am in the debug mode, I may still ask some load or unload mission, some mission to points, and so on. So here in the onNextMission function, you will write the missions that AGV will do. But remember, in order to ask an AGV to make a mission, it must be in automatic, so you must already have finished the initial point procedure and you must not be in manual mode. Then you must enable the AGV, that, as you know, is right-clicking on it and enabling, or you may press this button to enable all the AGVs. And finally, you must, of course, not having already another mission to do. While these three conditions are met, the AGV will automatically call this function, and then it's up to your code to dispatch to it the mission that's requested. You will see in case of your plant what is the most important mission to do, if current AGV is available, if the zone is not some kind of forbidden zone, and then the AGV will register a mission. And according to mission register, we come here, register mission. Here we just make it easy. We again check whether the vehicle exists, we check some other flags, and then we say, if the mission is already handled by the common part, just do the register mission in the common part and return. The common part, as we said before, is the X script of the common part. This is like the standard library of some parts of the AGV. I suggest you just to take a look on this on your own. But here you will just find some very basic functions like move to point. That's something that we do not care too much because, as you can see here in the selection of the missions, we already have by default in the default code the mission to point. In the mission to point, I will check if the start mission command has some error, I will return null. Okay, that's just safety. And then I will just say common register movement. It's a movement from the AGV to the parameter number 1. And then this is just the end of the mission, so the last macro I add is macro end. As you can see, this is just a standard mission. If you ask something strange, the default part will just tell you an alarm. Register mission that is unknown mission and just make null. Now, as we have said below, we have registered the missions, and according to the value of the new mission requested by the onNext mission function, we come here and we register. So after the starting mission, that okay is just to set the AGV in the mission status, we just add the macros. Macros, as I briefly explained before, they are actually all the phases of the function. So every macro is like a small function we would like to do. Imagine you have an FSM, a finite state machine, a Moore machine as you may know it. And so inside every state of your machine you have to do some kind of operation. Every state, every value of the state is just one macro. The AGV Manager just would like us to copy and just go back here at the beginning of the code. We just define all the macro with their numbers and just use the numbers you would like on your own, just the numbers to make them everyone different one to the other. And please never use two little numbers, because two little numbers are the ones used by the system, and please do not also use two big numbers. You may see here in the common script some of the macro have some big numbers, some of the missions have little numbers. So just use hundreds or thousands, or yes, even tens of numbers. So now here I say, I set this macro, then I register a movement, then I set this macro to posit, this is the mission to charge, for example. So I say, macro set the station charge. This is just a station that we write to the RP1. This is because in the RP1 is the Robox controller inside this AGV, we would like to know this information just because we would like to print on the HMI. So while in the big plant the AGV is moving, any people can just take a look on the digital dispan and just see that AGV will state a string writing, I'm going to charge station number 2. And so the user can know what the AGV is doing. Then we will register the movement, of course, to that point. And OK. Finally, There will be a macro to make a positioning to charge point. And finally, in this macro positioning, we will, for example, enable the relay of the battery loading, and we will exchange some data with the PLC to ask to the charger to start charging us. And then we will just wait to reach the RP1, so the Robox controller, to tell us that the battery has been fully charged. When that bit will be set true, this macro will finish. We will be ready, we will finish, and so we will clear the station number to the charger. In order to set it free, we set it to 0. It will be free for another AGV to reserve it and to go to charge, to make its own charge mission, and then just finish macro end. Now, for example, let's go and take a look at these kind of macros. As I said before, if you need to do a movement, just make the common register movement, AGV, and hyper1 is just the parameter of the motion. Normally it's the index of the station. It's called parameter 1 because here inside the function you see we have parameter 1, parameter 2, and if we want we may have up to 4 parameters. As you have seen, when we do register mission, let's go again to the on next mission. Every time we do a register mission, we say which AGV, which mission, and we say the next station, which is the target. So, while we go to register mission, here we have the AGV, the mission, and the first parameter, in my case, was the station number. And so here, this is why we say register movement to the station. In case we also have the parameter 2, which is the direction, we will set it. Imagine that the AGV has the socket to connect the battery only in the rear. So we will request the AGV to go to the charger station and get in there with a rear orientation. But normally, to make it more safe, we write it directly on the map. So remember that in the RAT you will need to draw that station and to set that the allowed orientation will be only rear. Imagine I come here. Imagine here I would like to set a charging station, and here I will set, I'm sorry for the Italian, but the direction is everyone, because the AGV can come leftwards, charge, and then go away rightwards. And orientation maybe could be left, right, transversal, longitudinal, backward, forward, everyone. Let's say we are only allowed to come backwards, so it means that the AGV must come in backwards, and with its rear part will arrive on this station and connect to the battery charger. That's an example of what we should do. But in case you want more safety, you can also tell here that you want AGV to come to the battery station in the requested orientation. Now, apart from this, as we said, we have other parameters. For example, we always say that parameter 1, which is in this case the charger index, we set it that we want to charge to this station, and so we will provide some data to the PLC telling that this AGV wants to charge at this station, and then again we will provide the same data to all the other macros. Now let's go and take a look at all of them. We want this, and let's go to the next. Alright, so here we go in another function, which is onExpand macro. The function is here. We have onExpand macro and onExpand micro. These two functions are the ones where there is the big select, which is the same as a C code switch command, you see, select and case. And here we just see, according to the macro code requested, we write all the macro, and we are requested to write here the code we want. Every macro will return true when it's finished, otherwise will always return false. For example, now we go to the charging part, here. Here we have the macro set station number charge. And here, for example, we say AGV register passes through. So I just want the AGV to write the mission and to write the P set station number, which is just the pass-through operation I want to enable, and I will give the station number. This pass-through operation, of course, has been declared at the begin. So it's here, set the station number. And now let's go again. Let's go, for example, to check here the micro. Here we have the micro are the same as the macro, but as I said before, micros are inside the macro. A macro can contain more micros. And micros are, for example, in this case, an operation. Like before, we have O-load, O-unload. In this case, O-load was defined as number 11, as we saw in the tooltip, like here. That's a blocking operation. So here in the micro operation, we will just say, I want to load. So just, if it is the last call of the operation, I will just say it in the report. Otherwise, I will check if there is an abort, and otherwise I will do nothing and just wait the system to work. In my R3 code, remember, here inside, in the programs, in the rules, I have to go to see the operation. Here, where we handle the operations, we will also have, we will check the execution of the operations. So for example, here, and I will check again with a select. For example, here we have the load operation. And here we will handle it inside the AGV. So in case of the load operation, the AGV must do something. For example, the AGV will be requested to move the forks outside, maybe to talk with the robot, maybe to talk with something else, and then just wait. You see, here we have a function, an execute of the load that we may find, and here in the load execution we will just set some phases, and now here we do nothing because that's just a sample code. But in case you have to do your own code, here you may just write something like enable some output, move outside some conveyor axes, and so on and so on. But remember, this is what you do inside the AGV. If you are talking with the PLC, that's something that we must do inside the AGV Manager, because as always, remember that AGV is like a horseman, so it's the man who is talking to other people and not the horse. So the horse can just be connected to the manager. The AGV will never talk to the PLC, will never talk to the database. The AGV will only talk to AGV Manager, and only the manager is the only master in the plant, and it's the only one allowed to communicate with other devices and systems. So, for example, now here we see if we have to talk, if we have to communicate with AGVs, in some case we may, I'm looking here if we can see, okay, here in the unload back we have an example. In the unload back, so after I unload with the AGV, I must bring back my axis. So, no, sorry, this is other thing. Here I set an output unload done. And now I wait an input coming from the PLC. Either I simulate or I must get this input from the PLC. While I get this input, I can say false to some outputs of the AGV working. I can execute an unload. This is just an internal operation to tell to the AGV to set true the bit loaded and to say that I have been loaded from the station number 1. And then something in emulation, okay, we do not care too much, return true because this micro has finished. Okay, now let's go back to the macro and let's take a look. We were in the charge station, and so we say set the station number, and so I will register this mission just to write the station number, and this will go to some register. As I said before, this is just something we will see on the HMI. Then we have a positioning. So, okay, in this case, it's just a simulation. We have a timeout. And we will set this timeout according to the timer we need to charge. And then here we wait the end of charge. Normally we should wait an input, but since it's simulated, I just say, okay, if the timer is finished, I will have a simulate charge timeout that it is some timer I will set again, and I will set the integer property of the reserved station to 0. And so it's done. And so after this the mission is finished, because I will just set a message, and here I have set again the timer, so the timeout of the charged battery, and so after this timeout will finish, the AGV will again be requested to go to charge. Like now we can see AGV number 3. Okay, this is mainly the key behavior of the AGV Manager script. So remember, everything you make only at begin is happening on application start. While your AGV are dropped to point, you have to do nothing, because this kind of function is already provided to you. Just open the AGV Manager, drag your AGVs to generic points or to station points, so user points, and they will just go. Other things, the on-update I/O is something you have to write on your own according to the I/O you have, talking to the PLC or talking to MySQL or to any kind of database you have. So here you will handle some handshake, some watchdog, some other kind of communication, and to enable and disable something to the AGV. While any AGV will just go to the on next mission while it is in automatic, while it doesn't have already another mission to do, and of course it is enabled. And here you will write the code you want to handle what mission should an AGV do. If there are some available missions, some AGV will be requested to do them. And then you will give a register mission function command. Inside the register mission, you will make per each mission the list of the macro inside it. And on expand macro and on expand micro are the ones that will explain what they should do. Wait for some input, set some output to true and false, or setting some operation inside the R3 code of the AGV, so the connection between the horseman and the horse, between the master and the slave. Apart from this, you should be now able to start. I suggest you to make some easy sample. You may, for example, make an example of some random movement in which you just go to the on next mission, you check, after you check that the AGV exists and some of these safety stuff, you may just imagine to create a random mission to a random station among the ones allowed by your map, and just send the AGV there. Then put just a macro with some timeout just to wait, and then make it happen again. This is the initial kind of mission, initial kind of program you can do to get familiar with Robox AGV Manager. If you have questions or if you want to know more, please ask to see the tutorials and see other videos on our Robox channel on YouTube. And so, hope you will keep learning the Robox system, and of course keep writing mails to Robox staff in order to ask us to answer to some of the more complex of your questions, and you will very quickly become an expert of one of the best AGV system of all the Italy, which is Robox. Thanks for your attention, and see you next time.